Hello folks, so in this last endocrine lecture video, we're going to be talking about selected endocrine disorders. Okay, just selected. So we're just going to be talking about 3 selected endocrine disorders. The first one is called the hyperthyroidism. Hyperthyroidism means you have too much thyroid hormone circulating in the bloodstream and obviously again based on the effects of the thyroid hormone T3 and T4, you need to understand that that has effects on, in this case, outward physical appearances. So we can actually see signs and symptoms just by looking at a person who has hyperthyroidism. FY, the difference between signs and symptoms, folks, is signs is it is discernible by a different person. Symptoms is, in this case, is highly subjective. So a person will say, I'm in pain. Well, you can't see pain. Okay. So here, the classical signs of hyperthyroidism are bulging eyes and an enlarged thyroid. An enlarged thyroid is termed as a goiter. Okay, now why do you have an enlarged thyroid when you have hyperthyroidism? So you have to think about what are the effects. Well, you need to again go back to the negative feedback loop, right? So we're gonna talk about that for a second here, but why do you have bulging eyes? Well, bulging eyes is because you have a high metabolic rate. That means you have a high heart rate and you have high heart rate and high blood pressure, and that high blood pressure and high heart rate basically pushes your eyes out of their socket, right? So you have to understand that there's arteries in the back of the eye. Those things become vasodilated. Lots and lots of blood are coming out of those arteries, and that actually pushes the eyes out of their socket. Okay, very, very, very scary thing, right? And obviously you look hyper alert just by looking at this person, this cartoon. You can see that they're hyper vigilant in this case, right? You know, again, because of that increased metabolic rate. They probably also speak as fast as I do. Of course, no one can speak as fast as I have. They're probably very jittery as well. And they probably have, in this case, elevated body temperatures. Okay, classical signs of hyperthyroidism. Okay, now let's go back to this goiter. Why is this thing enlarged? Well, the reason why this is enlarged, folks, is you have to understand what's going on with hyperthyroidism, right? So the hypothalamus, folks, right, is secreting, in this case, what is this called? Thyroid releasing hormone. So it is, so this is again from the hypothalamus, and thyroid releasing hormone stimulates obviously the anterior pituitary gland to secrete TSH. I guess follow me so far. Thyroid stimulating hormone, and obviously this stimulates this one to secrete T3 and T4, which is collectively called thyroid hormone. Okay. What happens, folks, is the reason why this is enlarged is because most of the time, what happens, folks, is the reason why you have hyperthyroidism is because T3 and T4 can no longer negatively feedback upstream. So that means they cannot shut off, right? So remember that symbol. They can no longer shut off the thyroid stimulating hormone, and they cannot shut off the thyroid, in this case, releasing hormone. Okay, there could be many other many reasons why this is. But what happens is because they are not shutting off TRH and TSH, this TRH is always going to be inducing the pituitary to release TSH, and TSH is going to keep telling the thyroid, make more T3, make more T4, right? And so what happens is the thyroid then becomes hypertrophic. The hypertrophic means to say it becomes enlarged. And the reason why it becomes enlarged is because you have to think about it, right? The thyroid is working hard to manufacture T3 and T4 because of these constant signals upstream telling it to manufacture T3 and T4. So that makes it hypertrophic, and an hypertrophic thyroid in this case is called a goiter. Okay, again, it's because of this failure for these 2 hormones downstream to turn off the upstream signals. Okay, so that is a classical hyperthyroidism. All right, now the next endocrine deficiency that we're going to be talking about, and since this is what's actually quite up to date here, is actually diabetes, right? So there's actually 2 types of diabetes. We actually have type 1 diabetes. Okay, it's called the insulin dependent diabetes mellitus, okay, IDDM, or type 2, which is also called non-insulin dependent diabetes mellitus, because you don't need insulin for this type, you need insulin for this type. and the first type 1 diabetes, what happens, folks, is, and maybe I should review what the insulin does. Insulin is released after you just ate. And the reason why insulin is released by the pancreas when after, like in this case, postprandial or after you eat, is because there's a lot of circulating, in this case, glucose molecules, right? Because what you've done is you've absorbed glucose molecules from the small intestine. So you have lots and lots of nutrients, not just glucose, but amino acids, fatty acids, glycerol, okay? Insulin, folks, is kind of like, in this case, a doorman. So what happens is when you have insulin and you have high circulating amounts of, in this case, for our purposes, glucose, but also know that this also works for amino acids, this also works for glycerol and fatty acids, they basically open up the doors to cells, okay, specifically muscle cells and liver cells, hepatocytes. And what happens, folks, is, so insulin then docks, okay, to a receptor on the surface of hepatocytes and the surface of muscle cells. And what happens, folks, then is then glucose then enters the cell, which means to say that the levels of glucose in the blood then decreases, right? So you just ate, let's assume, for instance, that now your blood sugar is 300, right? Insulin gets released. Because of insulin, all of this 300 or 200 of this 300 now enters the cell. So now this goes down to 100 because why? Because the 200 actually went into cells, right? So this is actually what insulin does. And insulin, what it does is it just tells cells to bring in glucose, bring in nutrients, in this case, not just glucose, but fatty acids and amino acids from the blood, especially after you just ate, okay? What happens is, there's a reason why you can have no insulin. First of all, you could have, in this case, your pancreas could have been traumatized. You could have a surgery that removed the pancreas. Now, if you have no pancreas anymore, you have no insulin. No insulin means to say that your glucose levels are just gonna stay in the blood because no one is telling cells to take in this glucose molecules. Now, why is this harmful for you? If you've ever seen molasses flow, molasses is high sugar, correct? What happens, folks, is high amounts of glucose makes your blood more viscous, thicker. When your blood is more viscous, you have a higher likelihood of, in this case, clotting, blood clotting, right? Because what happens is the flow of blood is now too slow because of the viscosity. So now areas in which you actually have capillaries, like the blood actually gets trapped. And what happens, folks, when you have a thrombocyte, when you have a blood clot, nutrients no longer go into a certain area and that area dies. Okay, this is why a lot of diabetics, especially people who have chronic diabetic for like long periods of time, they actually are missing fingers, they're missing toes. They actually have to get their legs amputated, their arms amputated. It's because of this thrombotic, in this case, right, problems due to like high density of glucose, which makes the blood more viscous, which prevents blood from flowing into its required areas. Okay, this is also the reason why people who have diabetes go blind. Okay, because obviously your eyes need, in this case, blood, good blood. But what happens is if the area to your eyes are closed off, guess what happens? Well, no blood goes there, and if there's no blood goes there, no oxygen goes there, no oxygen goes to an area, your cells die. And then if your eyes don't get enough oxygen, your whole eye as an organ dies. Okay, so this is again the problems with type 1 diabetes. Now, the difference between type 1 and type 2, folks, is in type 1, your pancreas has been shot. Your pancreas can no longer make insulin for one reason or another. You get a pancreatitis when you were young, you had a viral infection, you actually have a bacterial infection in your pancreas. Now your pancreas can no longer make insulin. So this is this can be treated by obviously insulin injections, right? So this is why people, you should only take insulin, folks, after you eat, right? You take a shot immediately after you eat. A lot of people I know for a fact, they say, oh, I'm about to eat, I'm going to take insulin. Haha, that's actually a problem. What happens when you forget to eat and then you took insulin? Bad things happen, okay? So type 2. Type 2, folks, is normally, in this case, we hypothesize as scientists that this is actually caused by morbid obesity, okay? And again, this is again like my analogy for this, folks, is again, insulin tells cells to open up to bring in this case, glucose. So again, they are dormant to make sure that glucose enters the cells. I'm gonna tell you the story of the boy who cried wolf, right? So basically, or maybe not. So let's say insulin keeps telling cells, oh, you have lots of glucose. Bring them in. You have lots of glucose. Why do you have lots of glucose? Well, because you eat Dunkin' Donuts 24/7. So if you eat Dunkin' Donuts 24/7, that means insulin is released 24/7. And what happens, folks, is now your cells, your hepatocytes, your liver cells, and your muscle cells, basically they say they don't listen to insulin anymore. They say, oh, insulin is just teasing us. He's been telling us to bring in glucose for the past, I don't know, 5 days. There's no way that this person has that much glucose for 5 days. And so what happens is the cells go deaf. All right? The cells, especially liver cells and muscle cells, go deaf. And when they go deaf from insulin, okay, and again, this is an analogy, what happens, folks, is then glucose can no longer enter the cell, regardless of how much insulin you actually have. All right? So that's the difference between type 1 and type 2 diabetes. Okay? Another, in this case, endocrine problems is actually this thing called gigantism and dwarfism. And this is gigantism, folks, is when you have too much growth hormone, right? This is actually the tallest man alive. I think he's Turkish, okay? And dwarfism is when you don't have enough growth hormone. And as you can see, I think this is the shortest man alive at one point. I think he's either Chinese or I forget already like what nationality he is, but this guy, the tallest man in the world, is actually Turkish, okay? You can see the difference in size there. So when you have too much growth hormone, when you were young, this is a very important thing, when you were growing up in your adolescence and in your childhood, you become a giant. Andre the Giant was like this. What happens, folks, is when you don't have enough growth hormone when you were younger, you become a dwarf, okay? Now here's the deal. If you have high growth hormone and your in this case, your growth plate's already set, what happens then is, again, when you're an adolescent, right, if you have high amounts of growth hormone, your epiphyseal plate, again, right, so if this was the bone and here's the growth plate, right, the growth plate gets stimulated to, like, again, hypertrophy, right, so you get taller, correct? Well, what happens, folks, if you no longer have a growth plate, let's say you're an adult, okay, I'm gonna erase this. If you're an adult and you no longer have a growth plate, and you secrete high amounts of, why did I do that? High amounts of growth hormone. Folks, since you no longer have a growth plate, it no longer grows, right, in length here. So that's called interstitial growth, right? What happens, folks, is it's gonna increase in thickness. Okay, and that's actually a specific, okay, a specific disease, or in this case specific disorder called acromegaly, meaning enlarged bones, and that normally can be seen on the jaw. So you can actually have an enlarged jaw, enlarged skull. You can have actually a protruding skull in this case, and that again is if you have too much growth hormone later in life when you no longer have any growth plates. Okay, so again, please, I hope that you understand these 3 basic selected endocrine disorders. This is definitely going to be in the exam.